Hi guys, sorry I'm not there today, but just make the best of these notes and hopefully you can understand how to solve systems by substitution even better today. But let's start with just a little review. So what are these systems we've been doing for the last couple days? Well, a system is this idea of having two different equations, but finding that one special point where the two lines intersect, that one perfect point, that one perfect situation that makes both equations true at the same time. So we've done questions like both number one and number two. Number one just says, does 3 comma 1 make this true? So basically we have our x and our y. So we have our x there. They tell us it's 3. So we're going to plug that in there and there. And then we know our y is 1, so we're going to plug it in there and there. And then it's just calculating to see if this works out. So if we plug that in, we would end up with 3 plus 3 times 1. Does that equal 6? Yeah, it does. And we'd end up with 4 times 3 minus 5 times 1. Does that equal 7? Well, that would be 12 minus 5. Does that equal 7? Yes, it does. So then our answer would be yes, it makes both it true. And we double checked our answer by plugging them both in. And they equaled 6 and 7. So number 2, this one says to graph where these are. Well, these are classic y equals mx plus b. I'll do my best freehand that I possibly can. So the first line, I'll do the green one here. So that one has a y-intercept at 4, a beginning point of 4, and then the slope technically would be 1, or even if I wrote as a fraction, it would be 1 over 1. So then I go up 1 over 1, do another point, draw as perfectly straight as I can. There I go. The second one I'll do in orange. Y equals negative 2x plus 1. So that one, let me drop into some orange here, has a starting point of positive 1. We already got that. But it has a negative 2 slope. So then I go down 1, 2 over 1. And then I draw that as perfectly straight as I can. And tough to tell freehanding it, but it looks like to me that that point is negative 1 comma 3. Of course, we could plug it in to double check. So if I just drop the negative 1 in for x and the 3 in for y. So does 3 equal negative 1 plus 4? Well, yes it does. And then if I plug it in there and there, does 3 equal negative 2 times 1 plus 1? Oh, negative 1, sorry, negative 1. So I would get, does 3 equal negative 2 times negative 1 would be a positive 2 plus 1. Does 3 equal 3? Yes, it does. So I am right, but luckily I have classic Desmos here just to prove it. I just typed in both equations and they did intersect at negative 1 comma 3. It's nice always having Desmos available to double check. Okay, let's get started here. So, moving forward, I like to think about the word substitution as a trade, a swap. If you're going to trade something, kind of the key thing, whether you use the word trade or replace or exchange or switch or, give and take, share, whatever you want to talk, whatever words you want to use for making a trade, making a switch. But regardless, the main idea as far as math goes is we need these to be equivalent. That idea that they are 100% equal. So just going to get right after it. Okay, if you have these two y equals equations, here's the beauty of it, okay, is that you know that a single y, literally imagine that one in here, one y is equal to two x's. Well, then you notice down here, this is also one y in this problem. So it's actually really convenient when you have y by itself. So if y and x, if these two are equal to each other, you could swap them, you could change their order, it doesn't matter. I could write 2x equals 1y. It doesn't matter how I write it, but the idea is right here is that if they are equal, they are the same. So that being said, notice this, in reality, this 2x is equal to 1y, so then couldn't I take this 2x and trade it for that 1y down there because they're equal? So think about it, if I bring this thing down here, it's basically like saying 2x equals the same as the x plus 5. Now I'm actually going to give you the answer right now. The answer is 5. And now hopefully you could see it because of course double 5 is equal to a 5 plus another 5. 2 5s literally. Okay, now it makes sense. So if y equals double a number and y equals a number plus 5, well the only way to double a number is to add it to itself. Okay, but just to kind of finish off and show the algebra here, remember when you have, let me switch over to the red pen here, when you have x on both sides, the classic thing to do is to subtract the smaller x, so that would be the 1x in this time, and that would leave me with 1x equals 5. Okay, so that's basically as simple as it gets. However, remember there are two letters in this situation, so don't forget we are looking for this. We are looking for the point of intersection. That's what we're looking for in this chapter. So think about that. I need an x number and I need a y number always. So I use the algebra to figure out x, but then I also have to plug x back in. So if I do 2 times 5, I get y equals 10. And if I do 5 plus 5, I get y equals 10. Either way, it doesn't matter what equation I plug it into. Y equals 10. So you are allowed to write it like this, where you write both answers separate and kind of circle it, or this way would be the best way to write your answer as an actual coordinate or a point and write 4, 10. Excuse me, 5, 10. All right, so that's a pretty basic one. So here's where I would normally have you try, but I'll try it for you since we're not working together. So hopefully you could take a break and try this one. I'm just going to, just for the sake of showing that they're both equal to 1y, so I'm going to say, well, technically this one is equal to a y, and so it's also equal to that y in this problem. So I'm just going to take it and I'm going to go upwards. I can do that. I can swap it for that y. It actually doesn't matter which one I do. So that would leave me with negative 3x plus 14 equals x plus 6. The clever move here would be to add 3x to both sides to cancel that one out, because negative 3x is technically smaller, and that would leave me with 14 equals 4x plus 6 minus 6 from both sides, and I get 8 equals 4x. You can probably already see the answer. Divide by 4, divide by 4. X equals 2. Don't stop. That is just x, but don't forget you're looking for a point. So yes, you found your x number. Don't forget to plug it back in. So what's 2 plus 6? Well, that would be y equals 8. And then if you plug the 2 in here as well, that would be negative 3 times 2 would be negative 6 plus 14, which also equals 8. So check, check. The answer is 2, 8. All right, let's get a little tougher here. We don't usually see equations set equal to x, which is just a little strange, but hey, it can happen. And now you got to remember that this 1x is equal to all of this stuff. So I can literally grab all of this and make a little swap and trade it in for the x down there. So now this equation would now read 2y minus 4, that's the trade, plus the 8y equals 16. All right, so again, I just got that from trading right here with that x, since it was equal to 1x up here. Now I don't really need those parentheses because there's nothing being multiplied, there's no distributive property in this case. So I'm just going to erase those, put the plus back in there. I accidentally erased. So now be careful, this is one where the y's are on the same side as each other. So since they're on the same side, that's combined like terms. So that would turn into 10y minus 4 equals 16, and then just classic solving from there. Add 4 to the other side, add 4, you get 10y equals 20. You can probably already tell the answer is 2, but technically you would divide both sides by 10, divide by 10, and then you would get y equals 2. Well, this is strange. We actually ended up with y first. That'll happen. So now I just got to remember I got to take that y and plug it in for x. Well, if I'm going to be clever here, I'm just going to erase these markings. This first equation is literally equal to 1x, and that's my goal. So it would be smarter to plug in the y up here, because then I would get my 1x answer just from plugging it in. So I would have 2 times the y, which is 2 minus 4. So I get 4 minus 4, which is 0 in this case. All right. So technically this goes through 0, 2. So that's my x point. I can technically double check now too. If I plug in 0 here and I plug in 2 here, I would get 0 plus 8 times 2. Does that equal 16? Well, that would be 16 equals 16, so yes. All right, so what's awesome is I can double check and know for sure I got it right. All right, pause the video and try this one. You try it, pause it. All right, hopefully it went well for you. Now let's notice that the top equation is kind of stuck because x and y are on the same side and they're set equal to 8. But then I notice, oh, ding, 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 down here, 1y is by itself, so I can grab all of this stuff. I can grab all of it and trade it for the y up there since it's equal to 1y. So now up here I would write the 2x plus the y, but now we know y is equal to x minus 7. All right, so I swap this x minus 7, x minus 7, I swapped it in for the y there, so there it is, and then all of that is equal to 8. So these are on the same side, so combined like terms, 2x and another x would be 3x minus 7 equals 8. Add 7 to the other side, add 7 to the other side. I get 3x equals 15. You can probably already tell the answer is x is 5, but we'll just show our work and divide by 3 and divide by 3. And I get x equals 5. But remember, that is only the x number. You need to find the y number. Now again, because this one is equal to a single y, it'll be easier if I plug in the 5 right here. So I literally just end up with 5 minus 7. So y equals negative 2. All right, and I can just triple check by plugging the 5 and the negative 2 back into the top. I'm going to erase some of this work here, get out of the way, just so it's not so confusing. My answer is 5 and 2. And just to double check, I can plug it into the top as well. 5 is x, negative 2 is y. So I get 2 times 5 plus negative 2. Does that equal 8? Well, that would be 10 plus negative 2. Does that equal 8? Yes, it does. Okay, so I even double checked up there. All right. Number 3. This is as hard as it gets. The problem with number 3 is, do you have x by itself? No. So you can't use x. Do you have y by itself? No. So you can't use that either. So that being said, this is one of those problems where you're going to have to do a little work to do a little work, as I often say. So taking a look, the one little thing I notice here is this is kind of a single x, but y is also on that side, so that's not very helpful. But if I would just, in one move, add 4y over to the other side, now my equation would say x equals 4y plus 11. I move the 4y over to the other side. So now if I use a little iPad magic here, it's like I rewrote that equation entirely and changed it so I did get 1x by itself. And now I do a little grab here, drag it up here. Oh, can't see it with the white out. I thought I could be cool. So I'm just going to take it here. And so now I know 1x is equal to all of this stuff, 4y plus 11. So I'm going to grab all of this stuff and trade it in for the x in this problem. What makes this so hard is now my equation would say 4y minus 5 times all of that stuff that I traded. I traded 4y plus 11 all for one single x, and then all of that just equals 9. Well, this is just going to be a little bit of a tougher algebra problem because I got some throwback ideas. I have to think about distributing a negative 5 here first. So I'd have 4y minus 20y plus, or excuse me, not plus, a negative 5 times 11 would be minus 55 equals 9. All right, I notice I got some y's on the same side here, so I'm going to combine like terms. 4y, take away 20y, that would be negative 16y minus 55 equals 9. I'm going to add that 55 to the other side. Cross that out, and that would leave me with negative 16y equals 64. Oh, believe it or not, after all of that, I do actually know that 16 goes into 64. I'm going to divide both sides by negative 16. And after all that work, I get y equals negative 4. All right, so you do all that work, and you got to remember, my answer is a point. I've only found half of it. I know my y is negative 4. So I'm going to take my answer and I'm going to plug it in here to figure out what my x would be. So I have 4 times negative 4 plus 11 equals x. So x equals negative 16 plus 11. So x equals negative 5. That goes there. So now I finally have my answer, and I can double check by plugging in. This is what you got to be careful here. The x number, negative 5, I could plug it in there, but then the y number actually goes, so I'll use blue, the negative 4 would go there. That's quite the crazy double check. I'm going to have to erase some of this work out of the way. And I would get 4 times negative 4 minus 5 times negative 5 equals 9. All right, so that would be negative 16, and then the negative 5 times the negative 5 would turn into a positive 25 equals 9. And if you combine negative 16 and 25, you do get 9 equals 9. Oh my goodness, it works. I double checked, boom, boom. 100% negative 5 comma negative 4 is my answer. All right, so that leaves you with a couple to try there, guys. Give those a try. Thank you for listening. You have homework that has the answers on the back. If you didn't finish 6.1c, finish that. Tonight you'll have 6.2b. The answers are on the back. And then give that lesson check your best effort. Thanks, everyone.